Hey everyone, welcome to day two of volumes of known cross sections. So we're just going to start with a quick little recap of what you should have remembered from yesterday. So a volume of known cross sections is when you take little slices of some shape and use their areas to add together to get a volume. So this loaf of bread is kind of a good example of what we're talking about over here. So each slice of bread, you would find the area of it, and then you would add them all up to come up with the volume of the bread. Okay, so a couple of things you'll want to do when you're doing any problem with cross sections is start with a diagram, pretty big deal. You want to determine a formula for the base of the shape if it's not given to you. Determine a formula for the area of one cross section. This is kind of where all the work occurs. And then integrate the area of the area formula to determine the volume of the shape. So here's the calculus part. So four kind of main steps that you'll want to use every time you do one of these problems. All right, so we're going to start with this problem. We have four total that we're going to talk about today. So this one says, find the volume of a solid created when the base of is a circle of a radius 4 and the cross section is perpendicular to the x-axis are squares. So we've got our circle here, and this is going to represent part of our cross section. I'm going to draw the rest of it, probably not very well, but I'll draw it anyways. It's supposed to be a square. Looks kind of like a rectangle. Hopefully you get the idea. So the first thing I'm going to do, draw a diagram, got that done. Second thing, write the formula for the base. So the base is a circle with a radius of 4. So that's represented by x squared plus y squared equals 16. The cross sections are going this way from left to right because they're perpendicular to the x-axis. So that means we're adding them up this way, which means I need to solve the problem for y by itself or in terms of x. So I get y equals the square root of 16 minus x squared. That is what would represent actually this upper half of the circle. Since I need the square to have a full base, right now that only represents this portion of it, I'm going to double it to represent the whole entire side or the whole entire base. So 2 times 16 minus x squared is one side of the square. And now we need to find the area formula. So this is one of our steps. So the area of a square is just side squared. So it looks like this. And now we're going to integrate this. So I'm going to pull the 4 out front, but before I do that, I'm going to decide how I'm going to integrate. So I prefer to use 0 as often as possible. So I'm going to start at 0 and go to 4, but that only gives me half of the volume, so I need to double it. So I need to multiply this by 2, and there's already a 4 I'm multiplying by, so 2 times 4 is 8. So now I'm going to integrate this. So 8 times 16x minus x to the third over 3. I'd say you'll find about half of these problems are calculator and the other half are going to be non-calculator. So I'm going to do them without a calculator as often as I can so you can see the work that would be involved. Okay, so I have this. Luckily, 0 is in the mix, so it makes me only have to substitute the value in once. Okay, my thing is not cooperating here. All right, so 8 times, let me scroll down a little bit. 16 times 4 is 64. 4 to the third is 64 over 3. Again, 0 just gives me 0. This whole thing simplified and multiplied out becomes 1024 over 3. All right, remember you can always pause the video anytime you need to rewatch or rethink. Okay, problem number 2. Find the volume of a solid created when the base is a right triangle formed by the x-axis, the y-axis, and the points 0, 3, and 4, 0. So I'm connecting those 2 points to make a line, and together these 3 things make a right triangle. And the cross sections are semicircles that are perpendicular to the short leg. So this is the short leg, so my cross sections will be perpendicular to the short leg. So here is a kind of a semicircle. And we will keep creating more semicircles going up, which means this is a dy problem. Half of the distance between the y-axis and this line gives me my radius. So I need to first figure out the equation of this line, then take half, solve it for x in terms of y, take half of it, and then use that to find the area of the circle, semicircle. Okay, so now that I just confused you, let me go ahead and start. So the first thing I'm going to see is I have a slope of negative 3/4. So I'm going to write the equation of the line using the y-intercept. So y equals negative 3/4 x plus 3. But remember, we said we needed this in terms of y solved for x because this is a dy problem. So now I'm going to just solve it for x. So that becomes x equals negative 4/3 y plus 4. That is the length of this line, or that is the distance from the y-axis over to this line over here. So half of that would be half, or the radius of this circle. It would be, kind of think of it like this half. So the radius will be equal to 1/2 of this thing. And then I need to find the area of this. Well, the area is a semicircle, so that's going to be 1/2 pi, or pi over 2, times the radius squared. Well, the radius squared is, sorry, I'm making sure I don't forget anything here, 1/4 times, you know what? I guess this is what my pause was for here. I think instead of squaring it that way, I'm going to distribute first. I'm going to distribute the 1/2 into the problem. That'll actually make my life a lot easier, and yours too. Okay, let me make that skinny again. So the radius is actually equal to negative 2/3 y plus 2. I didn't really want to square this and square that. All right, so now this is my new radius that I'm going to put into my area formula and square it. So negative 2/3 y plus 2. I am actually going to square this because I'm going to do this without a calculator. So this becomes 4/9 y squared minus 8/3 y plus 4. Okay, so then I need to figure out the bounds of this because this is what I'm integrating, and I am going up. So I'm going to go from 0 to 3. I'm going to put that pi over 2 up front, go from 0 to 3, 4/9 y squared minus 8/3 y plus 4 dy. Okay, by hand, this becomes 4/27 y to the third minus 4/3 y squared plus 4y. And I'm integrating from 0 to 3. Okay, substituting 0 in is very nice, so I have to worry about that part. Substituting 3 in gives me pi over 2 times, looks like I'm going to just get a 4 out of that part, 4 minus, this is going to be a 12 plus 12. So everything simplifies quite nicely here down to 2 pi. So this would definitely have been a non-calculator question. Okay, problem number 3, another circular base problem. Find the volume of a solid created when the base is a circle with a radius of 3. So while I'm thinking about that, that equation is x squared plus y squared equals 9. And the cross sections are perpendicular to the y-axis and are equilateral triangles. So perpendicular to the y-axis, equilateral triangles, ooh, like this. Okay, so one thing I want to remind you of, either remind you of it or state it for the first time, depending, is that the area of an equilateral triangle can be written as side squared times the square root of 3 over 4. You could get there in other ways, but I really like to use this formula. It saves me, I feel like, a few steps. This is half of the side of the equilateral triangle. So I'm going to write that actually in terms of y, because this is a dy problem again, and then substitute that in here to find the area. So this is going to become x equals the square root of 9 minus y squared. Again, that's only half of side. So the whole entire side will be 2 times 9 minus y squared. So that's going here. And I'm going to be integrating this, and I'm going to do just like I did before. I'm going to go going up this time, right? So I'm going from 0 to 2, but I'm going to double it. And it's side squared, so this thing squared, 4 times 9 minus y squared, all over 4. And I just managed to leave out my root 3, so let me put that here. I was going to put it over here, but that seems silly. I'm just going to stick it out front right now. Okay, so now I'm integrating this. I'm going to cancel the 4's. 2 root 3 times, now I've got 9y minus y cubed over 3 from 0 to 2 gives me, this looks like this is going to be, oh, I said 0 to 2. You guys are going to have to stop me when I make these silly mistakes. It is clearly not 2. It is clearly a 3. I don't know why I chose a 2. So sorry about that. That is actually going to 3. I would stop the video, but this is my 3rd time through, so we're just going to go ahead and go through this. All right, we're integrating from 0 to 3. 9 times 3 is 27, and then 27 divided by 3 is a 9. 27 minus 9 is 18. 18 times 2 is 36 root 3. Okay, last but not least, this last one we will use Desmos for. So it says that we have the region R, so this is the region R, in the first quadrant that is bounded by the graphs of y equals sine of pi x and y equals x minus x squared. A solid is formed having circular cross sections perpendicular to the x-axis with diameters in R. So the diameter is running the distance between these two functions perpendicular to the x-axis, and they are full circles this time. So that means my area will just be pi r squared. And r squared is the distance between these two functions. So really, when I write my r is just the distance between these two. And technically, it's not even going to matter which one is the top function and which one is the bottom function, because I'm going to square it anyways. So this is my radius. So this minus this. And then my radius squared is this thing. Now I gave you the graph, so you can easily see that the intersections are from 0 to 1. However, if you didn't have a graph, you'd have to do this someplace else, because this is not something that you'd be able to solve. So we are going to go to Desmos, hopefully. I'm clicking on it. There we are. Okay, so I've graphed both of them. So sine of pi x is the red graph, and x minus x squared is the blue graph. And you can see clearly that the intersection points are 0, 0, and 1, 0. And remember, we only want the area in the first quadrant. Okay, so what we're going to do now is we are going to set up an integral with what we just had out front there. So remember, it was the integral. Let me go back to it so I can write on it, because I can't write on Desmos here. So let me go back and set up the whole integral. So this is r squared here. This is my, it is not r squared. See, it's a good thing that we went back to it. So my r is actually not this, but is instead half of that, because this is the whole entire diameter. So what I given you before was the diameter. This is actually the radius. So when I square the radius, I get a 1/4 out front, and this is squared. So then when I go to write the integral, I'm going from 0 to 1. And remember, it's pi r squared, so this is the r squared part. Sorry, I'm going to take the 1/4, factor it out front. And then it's going to be this r squared here, and then this is in terms of x. So this whole thing is still what I'm integrating. I just need a pi over 4 out front. So we are going to now go back to Desmos and have Desmos calculate it for us. So pi divided by 4 goes out front. And then the integral, if you just type int, it'll put the integral sign for you. It's going from 0 to 1. And I am going to just do f of x minus g of x, and then the whole thing squared dx. And so there is our actual answer of 0.216. So because of the sign and the x's being kind of a mess, this is definitely a decimals or calculator question. If you are still unsure of how to use your calculator to do this stuff, make sure you ask your teacher tomorrow in class. So this is 0.216. All right, hope you wrote down any of your questions that you might have, and we'll see you tomorrow.